Dear students, welcome. This is our 8th class on reduction formula. Let us start. Let us take one problem. If un equal to, let us take one problem. If we un equal to integration 0 to pi by 2 x to the power m sin mx dx, then prove that un equal to n divided by m square pi by 2 whole to the power n minus 1 minus n into n minus 1 divided by m square I n minus 2, where m is of the form 4r plus 1. We have to show that, you see, un equal to integration 0 to pi by 2 x to the power n sin mx dx, then prove that un equal to this. This is the reduction formula we have to prove. When the condition is n is of the form 4r plus 1. M is of the form 4r plus 1. Solution. Un equal to integration 0 to pi by 2 x to the power m sin mx dx. This is equal to, integrate this by parts, taking sin mx as the second function. X to the power m minus cos mx divided by m 0 to pi by 2 minus integration 0 to pi by 2 differentiation of the first function into integration of the second function, the integral of this. We have integrated this by the method of integration by parts, taking sin mx as the second function. You will write here integrating by parts, taking sin mx as the second function. Right here integrating by parts, taking sin mx as the second function, taking sin mx as the second function. Now you see here, if you put 0, it will be 0. If you put pi by 2, what will be the value of cos mx? We are given that m is of the form 4r plus 1. What will be the value of cos mx? Suppose this is number 1. Suppose this is number 1. Cos mx, this is equal to cos 4r plus 1x. Not cos, we are going to evaluate cos m pi by 2. Cos m pi by 2. This is equal to cos of twice r pi plus pi by 2. Twice r pi plus pi by 2. This is equal to again cos pi by 2. This is equal to 0. This means that if you put pi by 2, this term will vanish. This term will be equal to 0. If you put 0, here x is there, x is equal to 0. Therefore, no contribution from this term. This is equal to no contribution from this. Therefore, from 1 you will get. Therefore, 1 implies un equal to 0 minus 0. You will get 0. Minus plus n by m. Integration 0 to pi by 2. X to the power n minus 1 cos mx. X to the power n minus 1 cos mx. x to the power n minus 1 cos mx dx. Yes. This is equal to n by m. Integrate this by parts. In the question, what is un? Un equal to x to the power n sin mx. Here it is cos mx. You cannot write it here n minus 1. You cannot write it because it is cos. Therefore, you are to integrate again. Integrate again this by parts, taking cos mx as the second function. X to the power n minus 1 sin mx divided by m 0 to pi by 2 minus integration 0 to pi by 2 n minus 1 x to the power n minus 2 sin mx divided by m dx. Again integrating by parts regarding cos mx as the second function. You may write I am writing here integrating by parts. Integrating by parts. Taking cos mx as the second function. Cos mx. Cos mx as the second function. Integrating by parts, taking cos mx as the second function. Now, you write it here too. If you put, now you see, if you put 0, it will be 0. If you put pi by 2, what is the value of cos m pi by 2? It is sin m pi by 2. The value of sin m pi by 2. Now, sin m pi by 2, this is equal to cos 4r plus 1. Since m is of the form 4r plus 1, pi by 2. This is equal to cos twice r pi plus pi by 2. No, it is sin, it should have been sin. It should have been sin. Sin m pi by 2, sin 4r plus 1, sin twice r plus 1 pi by 2. This is equal to sin pi by 2 equal to 1. This time is not equal to 0, it is equal to 1. Therefore, from 2 you will get un equal to n by m, it will be equal to 1. Pi by 2 whole to the power n minus 1, 1 by m, and minus 0, minus n minus 1 by m, integration 0 to pi by 2, x to the power m minus 2 sin mx. You will get this one. This means un equal to m divided by m square, pi by 2 whole to the power m minus 1, minus m into n minus 1 divided by m into m means m square. Now you see, what is un? Un equal to integration 0 to pi by 2 x to the power n sin mx. You see here, x to the power n minus 2 sin mx. If un denotes the integration 0 to pi by 2 x to the power n sin mx dx, then this will definitely denote un minus 2. You may write here un minus 2. Un minus 2. Un equal to n by m square, pi by 2 whole to the power n minus 1, n into n minus 1 by m square, un minus 2. This is the required reduction formula. And proved. It has been proved. It is very simple. Let us take another example. Let us take another example. If I am, suppose I am equal to 0 to pi by 2, 0 to pi by 2, x to the power n sine twice p plus 1 x dx, where n and p are positive integer, where n and p are positive integers. Positive integers, then show that I am equal to, I am plus, you may write it here plus, n into n minus 1 divided by twice p plus 1 whole square I n minus 2 equal to minus 1 whole to the power p. N divided by twice p plus 1 whole square pi by 2 whole to the power n minus 1. Then show that this. We are given that I n equal to 0 to pi by 2 x to the power n sine twice p plus 1 x dx. N and p are positive integers. This integral is denoted by I n. If it is denoted by I n, then what will be I n minus 2? What will be I n minus 2? Replace n by n minus 2. Replace n by n minus 2 in both sides. You will get I n minus 2. We have to show that this. Hence deduce that. Hence deduce that this problem has already been solved in another way. Deduce that integration 0 to pi by 2 x cube sine raised x dx equal to 2 divided by 27 minus pi square divided by 12. Two parts of the question. First part is this. It is given. We have to show this. This is a reduction formula. We have to show this. And using this, we have to show that the integration 0 to pi by 2 x cube sine raised x dx equal to 2 by 27 minus pi square by 12. Now let us first try to solve the number 1. First part. Perhaps you have written the question. Now I am going to solve it. Now I n equal to this. This is equal to this. This is should be equal to x to the power n minus cos twice p plus 1x divided by twice p plus 1 0 to pi by 2. 0 to pi by 2. Minus integration 0 to pi by 2 n x to the power n minus 1, integrate this by parts twice p plus 1. Oh no, we should not write this one, because this bracket starts from here and it is closed here. Now you see n and p are positive integers. What is the value of this? Now cos twice p plus 1. If you put x is equal to pi by 2, then you will get this one. It will be a cos p pi plus pi by 2. P pi plus pi by 2. N is a positive integer. This means n equal to 1, 2, 3, 4 like this. Positive integer. Now, if p is equal to 1, it will be cos pi plus pi by 2. it will be in the third quadrant, therefore it is negative. It will be minus cos pi by 2, minus cos pi by 2 equal to 0. If it is 2, p equal to 2, because p is a positive integer, twice pi plus pi by 2, it will be in the first quadrant, it will be cos of plus cos of pi by 2, again 0. If it is 3, it will be in the third quadrant, minus cos pi by 2, cos pi by 2 is 0, it is 0, either plus 0 or minus 0, that means it is equal to 0. You will get this is equal to minus 1 whole to the power p, whole to the power p. If p is odd, then it will be minus. If p is even, it will be plus cos pi by 2 equal to 0. Since cos pi by 2 equal to 0, cos pi by 2 equal to 0, therefore this is equal to 0. And if you put 0 here, it is again 0. 0 minus 0, no contribution from this term. This means no contribution from this term. 0 minus 0, minus minus plus, n divided by twice p plus 1, integration 0 to pi by 2, x to the power n minus 1, cos twice p plus 1 x dx. If it is sine, it would have been, if it had sine twice p plus 1x, then this integral can be written as in minus 1. It is not cos. If it is not sine, it is cos. Therefore, you cannot write it as in minus 1. Therefore, you have to integrate it again by parts. Integrating again by parts, this is equal to m divided by twice p plus 1. First function x to the power m minus 1, sine twice p plus 1x divided by twice p plus 1, 0 to pi by 2, 0 to pi by 2, minus integration 0 to pi by 2, the differentiation of this n minus 1 x to the power n minus 2, it will be sine twice p plus 1x divided by twice p plus 1 dx. Bracket should be here. We have again integrated this by parts, taking cos twice p plus 1 as the second function. You may write in the right hand side within a bracket that integrating by parts, taking cos twice p plus 1 x as the second function. As the second function. Therefore, ion equal to this. Now, suppose it is number A. Just it is number A. Now, sine twice p plus 1 times of pi by 2. If you put 0, it will be 0 because x is here. If it is pi by 2, it will be pi by 2 to the power n minus 1. What is sine twice p plus 1 times of pi by 2? P is a positive integer. Now, sine twice p plus 1 times of pi by 2 equal to sine p pi plus pi by 2. If p equal to 1, if p is equal to 1, then it will be in the third quadrant. It will be minus sine pi by 2. If it is 2, then it will be in the first quadrant, it will be minus 1 whole square sine pi by 2. It can be written as minus 1 whole square sine pi by 2 plus sine pi by 2. If it is odd, simply it will be minus sine pi by 2, and if p is an even integer, then it will be equal to simply sine pi by 2. you may write here minus 1 whole to the power p times of sin pi by 2. Minus 1 whole to the power p times of sin pi by 2. Sin pi by 2 is equal to 1. It will be equal to minus 1 whole to the power p. Therefore, from A you will get, simply you may write A implies. This stands for, from the equation A we get I n equal to n divided by twice p plus 1. It will be pi by 2 whole to the power n minus 1. It will be minus 1 whole to the power p divided by twice p plus 1 minus n minus 1 divided by twice p plus 1 integral 0 to pi by 2 x to the power n minus 2 sin twice p plus 1x dx. It will be like this. It will be like this. Now, this means iron equal to this into this. You may write here n into minus 1 whole to the power p twice p plus 1 whole square pi by 2 whole to the power n minus 1. This again minus n into n minus 1 twice p plus 1 whole square. It can be written as I n minus 2. You see here, it can be written as I n minus 2 because x to the power n sin twice p plus 1x is denoted by I n. For n, it is n minus 2. Other terms are remain same. Therefore, you may write here I n minus 2. This is the required reduction formula. Now, let us try to solve the second part. What is second part? We have to show that. Second part. We have to show that integration 0 to pi by 2 x cube sin thrice x dx equal to 2 by 27 minus pi square by 12. The second part is we have to show that 0 to pi by 2 x cube sin thrice x dx equal to 2 by 27 minus pi square by 12. For that, we have to use the first part. What is the first part? We have already first part. Means I n equal to n into minus 1 whole to the power p twice p plus 1 whole square pi by 2 whole to the power n minus 1 minus n into n minus 1 divided by twice p plus 1 whole square I n minus 2. We have proved this one. What is this? That is integration 0 to pi by 2 x to the power n sin twice p plus 1x dx equal to, this is equal to n minus 1 whole to the power p divided by twice p plus 1 whole square pi by 2 whole to the power n minus 1 minus, you know, n into n minus 1 divided by twice p plus 1 whole square 0 to pi by 2 x to the power n minus 2 sin twice p plus 1 x dx. We have proved in the part 1 this. We have proved in part 1 this. Now we apply this to find the second part. Now you see, in the second part, x cube sine 36. For that, we have to put n is equal to 3 and p equal to 1. We have to put n equal to 3 and p equal to 1. N is equal to 3 and p equal to 1. We have to prove this. Put this. Now, suppose this is star. Putting n equal to 3 and p equal to 1. Putting n equal to 3 and p equal to 1. In star we get integration 0 to pi by 2 x cube sine 2 into 1 plus 1 sine thrice x dx. This is equal to n equal to 3 minus 1 whole to the power 1, 2 into 1 plus 1 whole square, pi by 2 whole to the power 3 minus 1, n is equal to 3, minus 3 into 3 minus 1 divided by 2 into 1 plus 1 whole square, integration 0 to pi by 2 x to the power 3 minus 2 sine you may write it here 6p equal to 1. You may write like this. Now you see. This means it is I3 0 to pi by 2 x cube sine thrice x dx equal to minus 3 by 3 square into pi by 2 whole square minus 3 into 2 means 6. This is 9. Integration 0 to pi by 2 h sine thrice x dx. You will get this. This is equal to minus, it will be pi square, this 3 cancel, pi square divided by 4 into 3, 12, minus 2 by 3. Now you cannot apply this this reduction formula because n is a positive integer. It is n is equal to 1. In the reduction formula, you got I n minus 2. If n is equal to 1, what will be I1 minus 2? Therefore, you will have to integrate this by parts. Minus cos thrice x divided by 3, 0 to pi by 2, minus integral 0 to pi by 2, 1 minus cos thrice x divided by 3 dx. This is equal to minus pi square by 12 minus 2 by 3. What is this? If you put 0, it will be 0. If you put cos x is equal to pi by 2, x is equal to pi by 2, thrice pi cos thrice pi by 2, it will be again 0. This is equal to 0 minus 0. Plus it is 1 by 3 integration 0 to pi by 2 cos thrice x dx. Cos thrice x dx. You may write here this thrice x. You may write here since cos thrice pi by 2 equal to cos of pi plus pi by 2. This is equal to minus cos pi by 2 equal to 0. Therefore, if you put x equal to 0, it is 0. Cos thrice pi by 2, it is again 0. Therefore, we have no contribution from this term, 0 minus. This is equal to minus pi square by 12 minus 2 by 9 sine thrice x divided by 3, 0 to pi by 2. This is equal to minus pi square by 12 minus 2 by 27 Sine 3 times of pi by 2 minus sine 0. Sine 3 times of pi by 2 minus sine 0. Now, sine, 3 times of pi by 2 is equal to sine pi plus pi by 2. This is equal to minus sine pi by 2 equal to 0. This is 0, this is not 0, this is 1. I am sorry, minus 1. This is equal to minus 1. Sine thrice pi by 2 equal to minus sine pi by 2 equal to minus 1. It is minus 1, sine 0 equal to 0. Therefore, you will get here, I am writing here, this is equal to minus pi square by 2, 12, minus 2 by 27, minus 1 minus 0, this is equal to minus pi square by 12, minus plus 2 by 27. This is equal to 2 by 27 minus pi square divided by 12. This is the answer. From this, 2 by 27 minus pi square by 12. Minus pi square by 12. We have applied the reduction formula to deduce integration 0 to pi by 2 x cube sine thrice x dx. The result is 2 by 27 minus pi square by 12. This problem has already been solved earlier in a previous class by another method. You may check it. Now I am going to solve another problem. Perhaps you have written all. I am giving you to write down. I am giving you the sums to write down. Perhaps you have written everything. Next question. If I am denotes integration 0 to a square minus x square whole to the power n dx. If I am denotes integration n is greater than 0. N is greater than 0. I am denotes this. Then Chandra, I am equal to twice m square divided by twice m plus 1 I n minus 1. Hence deduce that but hence evaluate integration 0 to a square minus x square whole cube dx. Just put n is equal to 3. You may integrate this in a very by applying a minus b whole cube formula. Then it can be integrated very easily in preliminary level of integration. Now, to find the value of this, we have to apply the reduction formula. First, we prove the reduction formula. Then we will use it to find the value of integration 0 to a square minus x square whole cube dx. You have written this. Now the solution is like this. I am equal to integration 0 to a square minus x square whole to the power n dx. A square minus x square whole to the power n dx. This is equal to integration 0 to a square minus x square whole to the power n into 1 dx. You may write like this. Now we shall integrate this by parts taking 1 as the second function. We shall integrate this by parts, taking 1 as the second function. Now, this is equal to first function a square minus x square whole to the power n. The second function, the differential integration of the second function 1 is equal to x minus because you are integrating with respect to x. 0 to a, the differentiation of this a square minus x square whole to the power n minus 1 into minus twice x. Integration of 1 is this. Integrating by parts, taking 1 as the second function. You may write here integrating by parts. You may write here integrating by parts. By parts. Taking 1 as the second function. Now integrating by parts, taking 1 as the second function. This is equal to, this means I am equal to. Oh no, I am very sorry, this is not pi by 2, this is a, 0 to a. 0 to a. We are integrating from 0 to a. It is not pi by 2, it is 0 to a. And in this I have written correctly. 0 to a. If you put x equal to a, what will be a square minus a square? It will be 0. If you put a, x is equal to a, this will be equal to 0. If we put 0, then this x, put x is equal to 0, 0 minus 0. Ultimately you will get 0 minus 0. Put x is equal to a, this term will be 0. Put x is equal to 0, this term will be equal to 0. The product is in all cases will be equal to 0. Plus twice n. Integration 0 to a square minus x square into x square. You may if for our convenience I am writing like this. Instead of writing minus plus twice and this is plus, this is plus. For our convenience, we have written minus twice and this is minus x square. This is equal to minus twice and integration 0 to a square minus x square. It is n minus 1. A square minus x square whole to the power n minus 1. For minus x square, you may write a square minus x square minus x square. You may write like this. Clear? Take this is a square minus x square one function and this is, it is ion. This means ion equal to minus twice n integral 0 to a square minus x square whole to the power n minus 1 plus 1 dx minus minus plus twice n square integral 0 to a square minus x square whole to the power n minus 1 dx. Am I right? This means ion equal to minus twice n plus 1 more. It is again ion plus twice n square. It is ion minus 1. This means 1 plus twice n ion. Take this term to the left hand side. Ion equal to twice n square I n minus 1. This means ion equal to, this means ion equal to twice n square divided by twice n minus plus 1. Twice n plus 1 ion minus 1 it has been proved. I have proved this one. In equal to twice n a square divided by twice n plus 1. The first part has been proved. What is the second part? We are to find the value of integration 0 to a square minus x square whole cube. A square minus x square whole cube. Suppose this is again give it as a number star. Suppose putting n is equal to 3 in star. Putting n is equal to 3. N is equal to 3 in star. We get I3 equal to 2 into 3 a square divided by 2 into 3 plus 1 I3 minus 1. I3 minus 1. This is equal to 6 a square divided by 7 I2. 7 I2. This is equal to 6 a square divided by 7. Again apply this. I will put n is equal to 2 here. 2 a square 2 plus 1 I2 minus 1. Again applying. Again applying star. Again applying star. This is equal to 2 into 2 4. 4 into 6 24 a to the power 4. 4 plus 1 5 35. It is I1. It is I1. What is I1? 24 a to the power 4 divided by 35. Integration 0 to a square minus x square whole to the power 1 dx. It is 3. We are calculating the value of I3. Means integration 0 to a square minus x square whole to the power 3. It is 1. This is equal to 24 a to the power 4 divided by 35. It is a square x minus x cube by 3. 0 to a. 0 to a. Now last part I am writing here. 24 a to the power 4 divided by 35. Put a cube minus a cube by 3 minus 0 minus 0. This is equal to 24 a to the power 4 divided by 35. You will get here 2 by 3 a cube. 2 by 3 a cube. 8. This is equal to 16 by 35 a to the power 7. The answer should be this. 16 by 35 a to the power 7. 16 by 35 a to the power 7. Answer is this. Perhaps you have written everything. Let us take another problem. Obtain a reduction formula. For integration. Obtain a reduction formula for integration whole to the power n by 2 dx. Obtain a reduction formula for whole to the power n by 2 dx. Obtain a reduction. Very easy. Just integrate it by parts regarding one as the second function. You may write integration x square plus a square whole to the power n by 2 dx. This can be written as x square plus a square whole to the power n by 2 into 1 dx. This is equal to first function into integration of the second function minus integration, the differentiation of the first function, into integration of the second function. Integrating by parts, taking 1 as the second function. Integrate this by parts, taking 1 as the second function. This is equal to x square plus a square whole to the power n by 2 minus 2 cancel n. You may write here x square plus a square whole to the power n by 2 minus 1 into x square dx. You may write like this. This 2 cancel, 2 cancel. You may write like this. This is equal to x into x square plus a square whole to the power n by 2 whole to the power n by 2 minus n into integral x square plus a square whole to the power n by 2 minus 1 x square plus a square minus a square, right? In this way. Take x square plus a square as one term, other term is minus a square. If you multiply this and this, it will be x square plus a square whole to the power n by 2 minus 1 plus 1. Consequently, you will get x square plus a square whole to the power n by 2. This is equal to x square plus a square whole to the power n by 2 minus n x square plus a square whole to the power n by 2 minus 1 plus 1 dx. It will be minus minus again plus n a square integral x square plus a square whole to the power n by 2 minus 1. And in the left hand side it was also x square plus a square whole to the power n by 2. Now take this term to the left hand side. It is plus 1 minus 1 will be cancelled. This term to the left hand side. You will get n plus 1 integration x square plus a square whole to the power n by 2 dx equal to x into x square plus a square whole to the power n by 2. The whole to the power n by 2, no integration sign is there. This plus n square integration x square plus a square whole to the power n by 2 minus 1 dx. This means integration x square plus a square whole to the power n by 2 equal to x into x square plus a square whole to the power n by 2 divided by n plus 1 plus n divided n square divided by n plus 1 integral x square plus a square whole to the power n by 2 minus 1 dx. Which is the required reduction formula? This is the required reduction formula. It is n minus 2, n by 2. If you put n by 2, if you put for n equal to n minus 2, you will get this one. N is equal to n minus 2. It is nothing but n minus 2 divided by 2. N minus 2, n by 2 minus 1 means n minus 2 divided by 2. It is n is divided by 2. And in the last answer, this integration to get this integration, we have put n equal to n minus 2. N equal to n minus 2. It is not, if you denote this by I am, if you denote this by I am, then it will be denoted by not I n minus 1, it will be denoted by I n minus 2, because n by 2, n divided by 2. Put n for n minus 2. N minus 2 divided by 2 means n by 2 minus 1. This one. Which is the required reduction formula? Which is the required reduction? Reduction formula. Which is the required reduction formula? I am giving you a chance to write down in your book. Perhaps you have written. Now, obtain a reduction formula for. Next question is, obtain a reduction formula for. Obtain a reduction formula for integration this. Obtain a reduction formula for integration 1 by x square plus a square whole to the power n. 1 by x square plus a square whole to the power n. Now let us denote I n equal to integration 1 by x square plus a square whole to the power n. This means, what will be I n minus 1? It will be 1 by x square plus a square whole to the power n minus 1. I n minus 1. Again we apply, we are going to apply the method of integration by the method of integration by parts. Now you see, what is this? X square plus a square whole to the power minus n. If you differentiate this, it will be minus n minus 1. Minus n minus 1. X square plus a square whole to the power minus n minus 1. This is 1 by x square plus a square whole to the power n plus 1. It is not reduced. But if you integrate this by parts, taking 1 as the second function, then if you differentiate this with respect to x, then you know x square plus a square whole to the power minus n plus 1. If you differentiate this, you will get minus n plus 1 into x square plus a square whole to the power minus n plus 1 minus 1. Means x square plus a square whole to the power minus n. This is equal to 1 by x square plus a square whole to the power n. This will get. This time we will integrate this by parts, not this. Now, very interesting. See, if I n minus 1 equal to integration 1 by x square plus a square whole to the power n minus 1 dx. This is equal to, you may write x square plus a square whole to the power minus n minus 1 into 1 dx. You may write like this, into 1 dx. Integrate this by parts, taking 1 as the second function. This time, now integrating by parts. Integrating by parts. Taking 1 as the second function. Integrating this by parts, taking 1 as the second function. I n minus 1, it will be equal to first function this. What is this? This is nothing but this. First function is this. First function. whole to the power minus n minus 1 means this. Into integration of the second function x minus integral the differentiation of the first function minus n minus 1 x square plus a square whole to the power minus n plus 1 minus 1. Now differentiate this. It will be twice x. Integration of 1, it is x. Right? This is equal to x divided by x square plus a square whole to the power n minus 1 minus minus plus n minus 2 times of n minus 1 2 times of n minus 1 integral integral 1 divided by x square plus a square whole to the power n into x square dx. X square. This means in minus 1. In minus 1 equal to x divided by x square plus a square whole to the power n minus 1 plus 2 times of n minus 1 integral. It can be written as x square plus a square minus a square divided by x square plus a square whole to the power n dx. This is equal to x divided by x square plus a square whole to the power n minus 1 plus 2 times of n minus 1 integral 1 divided by x square plus a square whole to the power n minus 1 minus twice n minus 1 a square integral dx divided by x square plus a square whole to the power n. Whole to the power n. This means in minus 1 equal to x divided by x square plus a square whole to the power n minus 1. What is this? Plus twice n minus 2. You may write like this. n minus 1. It is in minus 1 minus twice n minus 1 a square. It is in. It is in. This means in minus 1. This means now this is also in minus 1. Take this term to this to twice n minus 2 minus 1 into n minus 1. You may write like this. Write in minus 1 in one side. This side plus x divided by x square plus a square whole to the power n minus 1. This is equal to 2 times of n minus 1 a square in. This means in equal to this divided by x divided by this one 2 times of n minus 1 a square x square plus a square whole to the power n minus 1 plus twice n minus 3 divided by this one 2 times of n minus 1 into a square I n minus 1, right? Divide both sides by 2 n minus 1 a square, you will get x divided by 2 times of n minus 1 a square into this. Let me check. Twice n minus 3 divided by this. Which is the required reduction formula? This is the required reduction formula. This I am going to apply this reduction formula. I am going to apply this reduction. If I am equal to, next question is, if I am equal to integration 0 to infinity, suppose 0 to infinity, 1 by x square plus a square whole to the power m dx, then show that I am equal to twice n minus 3 divided by 2 into n minus 1 a square I n minus 1, and hence evaluate integration 0 to infinity 1 by x square plus a square whole to the power 4. Hence evaluate this. You see, if I am equal to this, we have to find a reduction formula. I think this reduction formula will be equal to this. I am going to apply a reduction formula, and that reduction formula will be applied to evaluate this one, 0 to infinity 1 by x square plus a square whole to the power. Number 1 minute, please. I am equal to integration 0 to infinity 1 by x square plus a square whole to the power n dx. Therefore, I n minus 1 will be equal to 0 to infinity 1 by x square plus a square whole to the power n minus 1. Now, as the previous question, 0 to infinity 1 by x square plus a square whole to the power n minus 1 into 1 dx. Now integrate this by parts, taking 1 as the second function. This is equal to first function 1 by x square plus a square whole to the power n minus 1 into second function x, 0 to infinity 0 to infinity minus integration 0 to infinity. You know, the integration of the first function and the differentiation of the first function will be equal to minus n minus 1 into x square plus a square whole to the power minus m plus 1 minus 1 into twice x, again x, which is the integration of 1. You see here. Now notice that if x is equal to 0, if you put x is equal to 0, it will be 0 divided by a non-zero number. It will be 0. If you put infinity, then it will be of the form infinity by L'Hospital's rule. differentiate the numerator and denominator. In the numerator it will be 1, and the denominator it will be n minus 1 x square plus x square whole to the power n minus 2 into twice x. Now put x is equal to infinity, it will be 0. In any case, there will be no contribution from this term, 0. If you put x is equal to 0, it is obvious, 0. If you put x is equal to infinity, infinity by infinity form. Apply L'Hospital's rule, then you will get 1 divided by this, 1 divided by infinity. You will get 1 divided by infinity equal to 0. No term from this. You will get this means in minus 1 equal to 0 minus 0 plus 2 times of n minus 1 plus 2 times of n minus 1 plus 1 minus 1 will be cancelled. X square divided by x square plus x square whole to the power n. Integration 0 to infinity. X square divided by x square plus x square whole to the power n. I am writing like this. Can I write this thing? For x square plus x square minus x square. I have written this. This means n minus 1 equal to 2 times of n minus 1 integral 0 to infinity dx by x square plus x square whole to the power n minus 1 minus, this is plus, it will be minus, 2 times of n minus 1 x square integral 0 to infinity dx divided by x square plus x square whole to the power n. Whole to the power n. This means n minus 1 equal to 2 times of n minus 1, it is again n minus 1 minus 2 times of n minus 1 a square, it is in. This means 2 times of n minus 1 a square in equal to 2 times of n minus 1 minus 1 in minus 1. This means in equal to twice n minus 2 minus 1 minus 2 minus 1 means minus 3 divided by 2 times of n minus 1 a square in minus 1. The first part has been proved. In equal to twice n minus 3 divided by 2 times of n minus 1 a square in minus 1. Now I am going to apply this to evaluate integration 0 to infinity 1 by x square plus x square whole to the power 4. X square plus x square whole to the power 4. Means I am going to apply, prove that I am going to apply when n is equal to 4. When n is equal to 4. We have established what in equal to twice n minus 3 divided by 2 times of n minus 1 a square in minus 1. I have established this. Where in equal to 0 to infinity 1 by x square plus a square whole to the power n. Putting n is equal to 4. N is equal to 4. We get integration 0 to infinity 1 by x square plus x square whole to the power 4 dx equal to I4 equal to 2 times of 4 minus 3 divided by 2 times of 4 minus 1 x square I4 minus 1. This is equal to 8 minus 3 means 5. 6 x square I3. Suppose this is star. We have established Dinudita star. You may write here applying star. Applying this. Again apply. Again apply. 2 into put L is equal to 3. Again applying star. Again applying star. This is equal to 5 by 6 square. 3, 4 square. I2. This is equal to 15 divided by 24 a to the power 4 I2. 24 a to the power 4 I2. Now again apply star. This is equal to 15 divided by 24 a to the power 4. I2 means again apply this. 2 into 1 minus 3 I2. 2 into this is equal to 15 divided by 24 a to the power 4. It should be minus 1. Twice square. I1. Not. It is not minus 1. It is 2. You see here. I am putting n is equal to 2 here. 2 into 2 minus 3. It is not minus 1. It is plus 1. Put n is equal to 2. I2 equal to 2 into 2 minus 3. 2 into 2 minus 1. A square. I2 minus 1. Yes. 4 minus 3 means 1. Twice a square. 15 divided by 48 a to the power 6 I1. Again applying star I1. This is equal to 15 by 48 a to the power 6. I1 means 0 to infinity. 1 by x square plus a square to the power this. Right? Whole to the power 4 has been reduced to 1, whole to the power 1. What is the integral of this? 1 by a tan inverse x by a. 15 by 48 a to the power 6, 1 by a tan inverse x by a. 0 to infinity. 0 to infinity. The remaining part, I am writing here the remaining part. This is equal to 15 divided by 48 a to the power 6 into 1 by a tan inverse infinity minus tan inverse 0. Tan inverse infinity minus tan inverse 0. This is equal to 15 by 48 a to the power 7 tan inverse infinity. It should be equal to pi by 2 minus 0. Pi by 2 minus 0. This is equal to 15 pi by 96 a to the power 7. (15 pi by 96 a to the power 7). In an alternative way, applying the reduction formula, we have now this may be 32. 5 pi by 32. This is equal to 5 pi by 32 a to the power 7. 3. Yes. 5 pi by 32 a to the power 7. 5 pi by 32 a to the power 7. Alternatively, just check it by doing it alternatively. Put x equal to a tan theta. This means dx will be equal to a sec square theta d theta. Dx will be equal to a sec square theta d theta. X equal to 0 implies theta equal to 0. X tends to infinity implies theta, this is equal to pi by 2. Theta will be equal to pi by 2. We have got 5 pi by 32 a to the power 7. Therefore, integration 0 to infinity dx by x square plus a square whole to the power 4 equal to integration theta equal to 0 to pi by 2. Theta is equal to 0 to pi by 2. For dx you may write a sec square theta d theta divided by the x square, means a square tan square theta plus a square whole to the power 4. This is equal to a divided by a square whole to the power 4. Integration 0 to pi by 2. Sec square theta, it will be tan square theta plus 1 whole to the power 4. Sec square theta whole to the power 4. Right? This is equal to a by a to the power 8 means 1 by a to the power 7. Integration 0 to pi by 2. Sec square theta and in the denominator sec to the power 8 theta will be equal to 1 by sec to the power 6 theta, means cos to the power 6 theta. Cos to the power 6 theta. You will get cos to the power 6 theta. I am writing the remaining part here. 1 by a to the power 7 cos to the power 6 theta. It can be written directly. This is equal to 5 by 6 into 3 by 4 into 1 by 2 into pi by 2. Now this 2. This is equal to in the numerator 5 pi. Denominator 4 into 2, 8 into 2, 16 into 2, 32. A to the power 7, the same result. 5 pi divided by 32 a to the power 7. 5 pi by 32 a to the power 7. Dear students, I want to stop here. Thanks for attending the class. Thank you very much.